Hello students, in this video we will see a very important reduction formula. Okay, reduction formula for integration of 10 to the power n x dx when n is greater than 1. Right. What happens, we can easily integrate when the power of 10 is less. That is, we can integrate 10 square x, 10 cube x, 10 to the power 4x, 10 to the power 5x. Even we can easily integrate 10 to the power 6x by the usual process. But if the power of 10 goes on increasing, suppose that we have to integrate the 10 12 10 to the power 12x. Okay, so by doing the integration through the usual process, it will take it is a lengthy process. Okay, so what happens, we will try to generate some formula, some pattern to find out the integration of 10 to the power n x dx when n is greater than 1, and n can be any odd or even number. Okay, but n is greater than 1. So let's do it. For that we need some basic concept. For example, here are the four basic concepts which are involved while deriving the process for the integration of 10 to the power n x dx, right? So first of all, we know that the derivative of tan x is sec square x, and hence the integration of sec square x dx is tan x, of course, plus constant of integration. Okay, and integration of tan x dx is log of mod of sec x, correct? And 1 plus tan square x equal to sec square x. This formula is very important while doing the integration of tan square x. So this tan square x we have to replace by sec square x minus 1. See why this is important, because the sec square x is standard integrable function, right? Because the integration of sec square x is tan x, and we can also integrate 1. Okay, that will be the x, right? So this function, ultimately this function we can evaluate. So what happens, whenever odd or even power of 10 x is there and we have to take the integration, there we have to take tan square x and then substitute tan square x equal to sec square x minus 1, and then we can find out the integration, right? So we will see how it helps to find out the integration of 10 to the power 3x, 10 to the power 4x, 10 to the power 5x dx. Okay, and then we will derive the formula. We will generate the pattern to find out the integration of 10 to power any number which is greater than 1, either odd number or even number. So that reduction formula will help us to find out the integration of higher power of the tan x in a very single step. Okay, we will see how. So let us start with the very elementary problem, that is integrate tan square x dx. Okay, tan square means already square power is 2 which is greater than 1, right? So definitely the tan square x can be now replaced by sec square x minus 1. Okay, so therefore the sec square x dx, that is the integrable function, right? 1 dx, we know that the integration of 1 dx, right? So here tan square x ka integration is equal to the tan x minus x, and of course the constant of integration. Okay, don't concentrate on the constant of integration, see over here. Okay, we will develop the pattern to find out the integration of tan x function for any power greater than 1, right? So just have a look over the answer. This is the question where we have to find out the integration of tan to power 2x, and as you can see in the answer here tan x. So first things you can think about that here in the answer we are one less power than the power there in the question. Okay. So tan square x is there, therefore tan x. That is straightforward. You can say that the uh, in the answer there is a one power less than in the question, right? So this is tan x, and again concentrate on this 1 dx. Okay, this 1 dx is also important. Why? Because tan x and then minus x is there. Okay, so we will see whether it is tan square x or tan cube x or whatever be the power of the tan x function greater than 1, the last term in the answer will be either x or log of sec x. Okay, see, come to the second question. Integration of tan cube x dx, right? So here again we can write tan x into tan square x and replace that tan square x by sec square x minus 1. So that will be the integration of tan x into sec square x dx minus tan x dx. Okay, now how we can integrate this? We know that the derivative of tan x is sec square x dx, right? So just put tan x equal to t, so that sec square x dx, this sec square x dx whole will be converted into the dt, and this is t. So therefore simple integration of t dt, which is equal to the t square by 2, and t is tan x, therefore tan square x by 2. And of course the integration of this tan x is log of mod of sec x. Okay, now look at the answer and the question here also. In the question there is the 3 as the power of tan x, and in the answer we started from 2 in the power of tan x, that is tan square, that is 1 less power, correct? Here also 1 power less, right? So, and because of that we have divided 1 over here, whatever be the power over here, that is divided, right? Got the point? So one thing is clear that the whenever tan square x or tan cube x or tan 4x, the answer, the very first term will be 1 power less than the power that is in the question, right? Correct. Now come to the third one, integration of 10 to the power 4x dx. Here we can write as tan square x into tan square x, and 1 tan square x can be replaced by 1 tan square x, and not both the tan square x. That is sec square x minus 1, mind it, okay? This is tan square x, okay? Then tan square x sec square x dx minus tan square x dx, right? This by putting tan x equal to t, so this sec square x dx will be converted into the dt. Therefore, we have only the integration of t square dt, that will be the t cube by 3, that is tan cube by 3, right? Then tan square x again replaced by sec square x minus 1, okay, here. So sec square x integration we know that the tan x, and 1 dx integration is x. Okay, mind it, here minus is there, right? This minus and this minus will become plus, mind it. So the finally you can see the answer and the question. Integration of 10 to the power 4x, 1 power come, so 1 power less हो गया, so that is tan cube x divided by 3, then minus 10x. See, here power is 3, here power is 1, so just 2 power we are subtracting from the first one, right? And then 1 dx. Here see, last term is log of sec x, last term is x, last term will be x. So the last term in the answer must be either x or log of sec x. Okay, so again we will see how this pattern we can develop. Okay, so come to the straightforward, the integration of 10 to the power n x dx, right? So here also we will split this 10 to the power n x dx as 10 to the power n minus 2x into tan square x dx. This tan square x means sec square x minus 1 dx, right? So 10 to the power n minus 2x into sec square x dx minus 10 to the power n minus 2 x dx, right? So definitely this will be t to the power n minus 2 whose integration will be 1 power plus 1, that is 10 to the power n minus 1 and divided by n minus 1. And this is, as we have seen, this whenever integration of 10 to the power n x dx is represented by in. So therefore the 10 to the power n minus 2 x dx will be represented by in minus 2. Okay, so this is one thing. Again we can use the same pattern for this integration. This is the integration, right? So in the answer we will have 1 power less, that is 10 to the power n minus 3 divided by n minus 3, like that. Okay, and this process will continue. How? See here, we can have the integration of 10 to the power n x dx as 10 to the power n minus 1 x by n minus 1. Okay, now simply from here 1 power less, right? Now from here 2 power less. Okay, so 10 to the power n minus 3 divided by n minus 3, again 2 power less. Okay, 10 to the power n minus 5 divided by n minus 5, again 2 power less, and so on. The process will goes continues, right? And mind it, we started from the plus minus plus minus plus minus. That plus minus will go alternatively starting from the plus sign, right? So from here we will just subtract 1 power less, and from here 2 power less. Okay, and plus and minus plus and minus, and we will continue. Okay, up to the that depends upon the power, okay, of the 10, right? So here, as you can see there, whenever in the answer the power of 10 is n minus 1, then here in minus 2, right? So power is n minus 7, therefore here in minus 8. Again we can see like that, 10 to the power n minus 1 x, n minus 1, 10 to the power n minus 3, n minus 3, n minus 3, therefore I to n minus 4. Okay, because we are interested up to this level only, we are interested up to this level only because of that. Okay, and suppose that we want to continue up to the next step also. So this is n minus 1, n minus 1, n minus 3, n minus 3, no problem, n minus 5 and n minus 5, and this is as n minus 5, therefore I of n minus 6, and because of that plus and minus. Okay, plus minus plus minus, here plus minus plus, and like that. So this is all about the reduction formula. Okay, how we will say this as a reduction formula? Because we are reducing the power of 10. Okay, starting from the 1. Okay, whenever there is the power n in the question, we have to integrate the 10 to the power n x dx. So just reduce the power of 10 from n to n minus 1. Okay, and then we will continue to reduce 2 power less. Okay, that is 10 to the power n minus 1 will now become 10 to the power n minus 3, and 10 to the power n minus 3 will become 10 to the power n minus 5, and the process goes on continue, right? That depends upon the actually the power of n, and then divide n minus 1 also, that is also there, right? So let us start with the problems directly now. So here is the first problem, integration of 10 to the power 7x. See, 10 to the power 7 hai, therefore answer will start from the 10 to the power 6. Okay, I will say only 6 by 6, right? So 6 by 6, then 2 power less 4 by 4, right? Then again 2 by 2, right? Now come to the last term. This is also very important. Okay, common error. We have seen that the students commit the common error in the last term. Okay, that last term I said that the either it should be x or log of sec x. Okay, that depends upon this power, right? So okay, here 6 by 6, 4 by 4. Okay, plus minus alternative sign, no problem. 2 by 2. Then what happens? See, this is 10 की power 2. So therefore this must be I1. I1 as it is I7, therefore I1 must be integration of 10x, and that is log of sec x. Got the point? Come to the next one. 10 to the power 9 x. So 8 by 8, 6 by 6, 4 by 4, 2 by 2. Okay, 2 by 2, therefore this is I1, right? 2 and a power, therefore this is I1, right? I1 means integration of 10x. Integration of 10x is what? Log of sec x, right? So this is the answer. Now come to the 10 to the power 10x. Okay, 10 is there, therefore 9 by 9, 7 by 7, 5 by 5, 3 by 3, 1 by 1, right? 1 by 1, 10 to the power 1, therefore this will be I0. I0 means 1 dx integration, right? Integration of 1 dx, right? So what is that? X. So therefore I said that the last term will be either x or log of sec x. Mind it, okay? That depends upon the power. We can generate the pattern over here also. Whenever the power of 10 is even, then the last term will be x, and whenever the power of 10 is odd, then the last term will be log of sec x. Okay, and that plus and minus sign depends. Okay, we will start with the plus sign, and plus minus, that goes alternatively, right? So this is about the reduction formula of 10. Okay, we will see the 2017 mains problem. Okay, the question is very bigger, but the answer is one liner answer. Okay, so if I to the in is representing the integration of 10 to the power n x dx, n is greater than 1, and I4 plus I6 equal to a 10 to the power 5x plus b x to the power 5 plus c, where c is a constant of integration. Okay, then what should be the value of a and b? Okay, so see, I4 and I6 is there. So we will start with the I6, right? So I6 will be the integration of 10 to the power 6x. Okay, by using the reduction formula, you can write this as a 10 to the power 5x divided 5, and then directly this will be I4, right? Correct? Plus and minus power 5, therefore I4 integration IA, right? So therefore this I4 will go this side, I6 plus I4, that is equal to 10 to the power 5x by 5 plus c, which is the constant of integration. Now you can compare this with this one, right? So therefore a must be 1 upon 5. There is no x to the power 5 terms, therefore b must be 0. So therefore 1 upon 5 comma 0 will be our answer, correct? So this is very easy once you know the reduction formula for 10 to the power n x dx, when n is greater than 1, and n can be any number greater than 1, whether odd or even. So what is the pattern? That in the answer we start with the one power less than the power what is there in the question, right? So if we, and there is the question of integration of 10 to the power 4x, then answer start with the 10 to the power 3x divided by 3, right? And then we reduce the power by 2 and goes on continue. Okay, and that last term will be either x or log of sec x, that depends upon the power of n, and the sign positive negative goes on alternatively, starting with the positive sign, correct? I hope that you people have understand this concept. Okay, in the next video we will see the reduction formula for cot to the power nx dx. Okay, thanks for watching.